In this video, we are going to start new chapter, solid state chemistry. At room temperature, matter exists in three states: solids, liquids and gases. The solids are the substances which have definite volume and shape, and as compared to liquids and gases, the solids, in case of solids, constituent particles are very close to each other. The smallest constituent particle of various solids, these are the atoms, ions or molecules, and the properties of solids depend upon the nature and arrangement of these constituent particles, that is atoms, ions or molecules. Now there are two types of solids: crystalline solids and amorphous solids. In case of crystalline solids, the constituent particles, these are orderly arranged. There is a specific arrangement of the atoms, ions or molecules, whereas in amorphous solids, the constituent particles are randomly arranged, or there is no specific arrangement. The crystalline solids are characterized by sharp melting point. In case of amorphous solids, melting point is not sharp. There is a range of melting point. When particular solid starts melting at suppose 300 degrees centigrade, then melting will continue up to 305 degree or 10 degree, like that. So melting points are not sharp, but in case of crystalline solids, melting points are very sharp. Crystalline solids are characterized by anisotropism. They are anisotropic. And what is the anisotropic? The properties, physical properties especially, like electrical conductance, refractive index, thermal expansion, when these properties have different values in different direction, then it is said to be the particular solid is anisotropic. And crystalline solids are anisotropic. It means these physical properties, values of these physical properties change with different directions or have different values in different directions. Whereas in case of amorphous solids are non-anisotropic or they are isotropic. The physical properties like electrical conductance, refractive index, thermal expansion, these properties, these are not changing, their values are not changing in different directions in case of amorphous solids. Examples of crystalline solids are sodium chloride, ice or other salts, some metals like sodium, gold, copper, some materials like diamond, graphite. These are the crystalline solids. And the examples of amorphous solids are supercooled liquids or pseudo solids. These are the amorphous, or coal tar, glass, plastic, rubber, butter. All these are the amorphous solids. Now some important terms used in solid state chemistry. The first term is, what is the meaning of crystal lattice or space lattice? The regular and three-dimensional arrangement of constituent particles in space, it is called as crystal lattice or space lattice. Already I told you solid is formed by the constituent particles, that is atoms, ions or molecules, and these constituent particles like atoms, ions and molecules, these are called as lattice points. The positions which are occupied by constituent particles in crystal, these are called as lattice points. And these lattice points, arrangement of lattice points, especially three-dimensional arrangement of lattice points, in a solid, it is called as crystal lattice or space lattice. Actually, space lattice, it is an array of points, that is the constituent particles. Now look at this these constituent particles highlighted with red and blue color. This is the arrangement of different constituent particles. Now when any two points are joined by means of line like this, then when two points are joined linearly, then we get a edge, and when particles are joined, four particles are joined like this, then we get a plane. So in a lattice points, by joining the lattice points linearly, we get edges, and by joining a particular lattice points aligned in a same plane, we get different planes. Now consider this plane formed by joining four lattice points. Similarly, consider another plane. This is the another plane formed by joining these 4 points. Now when these two planes are joined like this, then there is a formation of a one unit cell, the smallest repeating unit. This is the smallest repeating unit, it is called as unit cell. And crystal lattice, it is formed by repetition of this unit cell. As such, in a crystal, such a types of lines are not there, only there is an arrangement of atoms or ions, and these are the imaginary lines. These are the imaginary lines. This is very important. In practice, in solid, such a lines are not there, only there is an arrangement of atoms, ions or molecules. And when we imagine such a lines, then there is a creation of or formation of one geometrical entity or geometrical cube or any other structure, that is called as unit cell. Now as I said, in crystal lattice different unit cells are repeated, and in this way we get a lattice point like this. So this is what is a space lattice or a crystal lattice. So these two definitions are very important. That is, what is crystal lattice? Regular three-dimensional geometrical arrangement of constituent particles is called as crystal lattice, and the positions which are occupied by constituent particles in crystal, these are called as lattice points. So these dots, these are the lattice points, and this entire arrangement, it is the crystal lattice, and one repeating unit, that is the unit cell. Now next point is unit cell. What is the unit cell? The smallest repeating unit or geometrical entity, the smallest repeating unit in space lattice or crystal lattice, it is called as unit cell. So this is the space lattice, and this is one unit, it is called as unit cell, and these are the lattice points. So unit cell, it is formed by lattice points. Now geometrical shape of unit cell is same as that of macroscopic crystal. If macroscopic crystal is body centered cubic, then unit cell is also body centered cubic. If macroscopic crystal is simple cubic, then the type of unit cell is simple cubic. So geometrical shape of unit cell is same as that of macroscopic crystal. Now each and every unit cell, it is characterized by unit cell parameters. These are also called as lattice constants. Unit cell, it is characterized by the parameters or lattice points, and these lattice parameters are the three edges or vectors represented by small a, b and c, and three angles between these edges or vectors represented by alpha, beta and gamma. Now consider the unit cell. So this is the one edge, that is A. Parallel to this A, all the edges, these are A. So this is A, this is also A, this is also A, and this is also A. So all the edges parallel to A are taken as A only. Similarly, another edge right angle to this A, consider this B. This is the another edge, that is B. Parallel to this B, this one, this is also B, this is also B, and this is also B. And right angle to A and B, there is a third edge, that is C, and all the edges parallel to this C are taken as C. So you know A, B and C, these are right angle to each other. If A is a x-axis, then B may be a y-axis and C may be a z-axis. Okay. Now the angle between A and B, it is a gamma. Angle between B and C, it is alpha, and angle between A and C, it is a beta. Actually these angles not necessary all the time 90 degree, but for cube all the angles are 90 degree. Sometimes these angles may vary from 90 degree. In some cases angle may be less than 90 degree, it may be a 120 degree, like that. So these are the lattice parameters, the edges A, B and C and angles between them, that is alpha, beta and gamma. These are the lattice parameters. Now based on the edges and angles, there are different types of unit cell. Especially there are 4 types of unit cell. One is primitive unit cell. In case of primitive unit cell or simple unit cell, lattice points occupy 8 corners only. Such a unit cell is called as simple or primitive unit cell. Another type is face centered unit cell. In case of face centered unit cell, lattice points occupies 8 corners of unit cell as well as the centers of each face. There are 6 faces and lattice points occupy centers of each faces in addition to corners. Now third type of unit cell is body centered unit cell. In case of body centered unit cell, lattice points occupies 8 corners and there is one lattice point which occupy center of the unit cell. This is the body centered unit cell. And fourth unit cell is base centered or end centered unit cell. In case of end centered unit cell, the lattice points occupy the corners of unit cell, 8 corners of unit cell, and the lattice points also occupy the centers of 2 end faces. Here you can see this is the top face. There is one lattice point at the center of the top face and there is another unit point which is placed at the center of the base or bottom face. So this is end centered unit cell. This end centered unit cell is not that much common, but simple face centered and body centered unit cell, these are the very common in various crystalline solids. Simple unit cell, it is also called as primitive unit cell. So in this way, unit cell are of 4 types: simple, face centered, body centered and end centered.